Electromagnetic waves. In physics, electromagnetic radiation refers to the waves of the electromagnetic field propagating through space, carrying electromagnetic radiant energy. It includes radio waves, microwaves, infrared light, ultraviolet, X-rays and gamma rays. So let us study the characteristics of electromagnetic waves. Important characteristics of electromagnetic waves are: electromagnetic waves are transverse in nature as they propagate by varying the electric and magnetic fields such that the two fields are perpendicular to each other. Accelerated charges are responsible to produce electromagnetic waves. Electromagnetic waves have constant velocity in vacuum and it is nearly equal to 3 into 10 to the power 8 meter per second, which is denoted by C is equal to 1 root over mu 0 E 0. Electromagnetic wave propagation does not require any material medium to travel. The inherent characteristic of electromagnetic wave is its frequency. Their frequencies remain unchanged, but its wavelength changes when the wave travels from one medium to another. The refractive index of a material is given by n is equal to root over mu r E r. Electromagnetic wave follows the principle of superposition. The light vector, also known as the electric vector, is reason for the optical effects due to an electromagnetic wave. In an electromagnetic wave, the oscillating electric and magnetic fields are in same phase and their magnitudes have a constant ratio. The ratio of the amplitudes of electric and magnetic fields is equal to the velocity of electromagnetic wave. So C is equal to E0 B0. Energy is carried by the electric and magnetic fields of electromagnetic waves are equal. That is, the electric energy UE and the magnetic energy UM are equal. So UE is equal to UM. There is a vector quantity S called Pointing vector which represents the energy transferred by electromagnetic waves per second per unit area. So these are the characteristics of electromagnetic wave. What is electromagnetic theory? Electromagnetism is the phenomenon which deals with the interaction between an electric field and a magnetic field. Stationary charges in a system lead to an electric field and moving charges in a system lead to a magnetic field. The direction of electric field and magnetic field is always perpendicular to each other and the wave travels at the speed of light. The Scottish scientist and mathematician James Clerk Maxwell brought the correlation between electricity and magnetism for the first time using Maxwell's equation. Maxwell's four differential equation unified existing laws of electricity and magnetism such as Newton's law, Faraday's law, Kelvin's law and Ampere's law. So let us study about electromagnetic theory. Magnetic poles come in pairs that repel and attract each other just like electric charges do. The force of repulsion and attraction between two electric charges is inversely proportional to the square of the distance between the particles. An electric field in motion produces a magnetic field. A wire with electric current produces a magnetic field whose direction depends on the direction of the electric current. Properties of electromagnetic radiation. They can travel through empty space. Waves other than electromagnetic waves have to travel through some substance. For example, sound waves will need either a solid, liquid or gas to pass through. The speed of light, which is equal to approximately 3 into 10 to the power 8 meter per second, is always constant. Wavelength is commonly characterized by the symbol lambda. It is the measure between the distance of either throughs or crests. Characteristics of waves. First one is wavelength. Wavelength that is denoted by lambda, is the distance between successive crests of a wave, especially points in an electromagnetic wave or sound wave. It can be simply defined as the distance of one full cycle of the oscillation. If lambda is the wavelength, c is the speed of light, and v is the frequency, then c is equal to lambda v. Then second one is amplitude. Amplitude is the distance from the middle of the wave to the maximum vertical displacement of the wave. The shorter the wavelength, greater the frequency, and greater the frequency, higher the energy. So, larger the amplitude, higher the energy, and lower the amplitude, lower the energy. Third one is frequency. The number of cycles per second is defined as frequency. It is defined as Hertz. If E is the energy, H is Planck's constant, which is equal to 6.62607 into 10 to the power minus 34, and V is the frequency, we can derive the relation given below. E is equal to HV. Period. Period is commonly characterized by the symbol T. It is the total time which a wave takes to travel one wavelength. Then velocity. Velocity is equal to lambda v, where v is the frequency. So guys, we just briefly discussed about electromagnetic waves. For detailed study of this chapter, you can visit to our website www.syft.in. Thanks for watching us.